Okay, straight into it then. Question 1. I've got the moles here, and I've got 0.50 moles of ammonia. And the question is, how many moles of magnesium hydroxide do I have? Well, you can use a simple ratio. 3 is to X, as 2 is to 0.50. 3 is to X, as 2 is to 0.50, which gives me 3 times 0.50 is 2X. Divide that by 2, which is going to give me 0.75, isn't it? 0.75. So that's my answer, 0.75. So 1 is C. Correct. And we're off. Question 2. Put in the integers here. Ooh, I see the answers have some nasty numbers. Oof. Okay then. I'm going to use fractions and then just fix it. So I see I've got 3 carbons on this side, so I must have 3 on that side. And 6 hydrogens on that side, so I must have 3 here. Now with the oxygens, I've got 6, 7, I've got 9 oxygens. But I need 9 oxygens on this side, and I've got 2 oxygens on that side. So if I put 9 over 2 here, that's going to work. Now that isn't the answer because it needs to be integers. So what I'm going to do is I'm going to double everything to make that 9, 6, 6. What's the sum of the integer coefficients? So I have to add them up now. Oh, and that was a 2, of course. 9, 10, 11, 23. So the answer is D. 2 is D. Yep, I solved with fractions first. Question 3. Okay, that looks like I'm going to use P1V1 over T1 is P2V2 over T2. I thought PV equals nRT. Well, you know, the N is the same and the R is the same. And so because that's true both at the beginning and at the end, you can use this equation, which kind of erases the N and the R. So what's the volume of a gas? A pressure on 100. So that's going to be 100 times 400 is changed to 200 times V2. There's no mention of temperature, so I'm going to ignore the temperatures. And that just gives me this simple equation. Divide each side by 200 to get me, so that's 200, isn't it? So V2 is going to be 200. 200, which is C. Yep, 3 is C. Question 4. Okay, so concentration is moles over volume, but we've not given you moles, we've given you the mass, and you can work out the molar mass. So actually, moles is mass over molar mass. The mass is 20. The molar mass of sodium hydroxide is 40. And divide by the volume, you might think that's 500. No. It's 500 divided by 1,000. You need decimeters cubed. So that's going to come out at 0.5. So 20 over 40 is 0.5 over 0.5. Well, that's 1, isn't it? So 4 is C. Yep. 4 is C. Question 5. What's correct for sulfur? Well, let's have a look. We've got protons, neutrons, electrons. So the small number is the atomic number, and that's always the protons, so that has to be 16. The difference is the number of neutrons is the difference, so that's going to be 18. And because it's got a 2- charge, that means that the sulfur has gained 2 electrons since it was an atom. So it used to have 16 electrons, but now it's got 18 electrons. So it's 16, 18, 18, which is D. 5 is D. Question 6, line spectra. So anything that goes down to n equals 1 is UV. Anything that goes down to n equals 2 is visible. and anything that goes down to n equals 3 is infrared. Big jump, big energy. That's how I think about it. The biggest energy there is ultraviolet, so that's going to involve the biggest jumps down to n equals 1. So we're looking at D, isn't it? 3 to 2. 3 to 2. Yes, so that's going to be D. 6 is D. 7. What's got the same value for all elements in the same period? Okay, so let's go to the periodic table. Well, I know that in period 1, they all have one main energy level, one shell. Period 2, they have 2 shells. Period 3, they have 3 shells. So that sounds like that might be the answer. Highest energy level occupied. So 7 is A. Yeah, 7 is A. Main energy level, that's just another word for shell. Let's have a quick look at the distractors. Energy sublevel occupied, oh, that's the SPDF. No. Orbitals occupied, that's to do with the number of boxes. Remember that D has those 5 boxes. Each box is an orbital. No. And valence electrons, well, that's going to be the group, isn't it? The group, it indicates the valence electrons. Question 8. What properties change down group 17? So group 17, let me think, what do I know? What changes? Well, the electronegativity of fluorine is the highest of anything. So the electronegativity is going to go down. And as you also go down, they're going to get bigger as well, aren't they? Chlorine has 3 shells and iodine has 5 shells. Those are the easy ones. And melting point. I know that fluorine's a gas, so it has a low melting point. Hey, it's already melted, it's already boiled, it's from temperature. It's a low melting point. And iodine has a high melting point. Oh, ionization energy and ionic radius. So none of that was what we were talking about. All right, let's look at ionic radius. Well, they all gain 1 electron, don't they? So the reason that fluoride is smaller than chloride is because it's got 1 less shell. And the reason that chloride is smaller than bromide is because chloride has 1 less shell. So as I go down, the ionic radius increases. So it has to be B or it has to be C. Ionization energy, that's how easy it is to pull an electron off. That's how I think about it. Okay, it's not easy, it's how much energy it takes to pull an electron off of a gaseous atom, standard conditions. But how easy it is to pull an electron off. Now, is it easier to pull an electron off of fluorine, or is it easier to pull the electron off of bromine? Well, nothing loves electrons more than fluorine, does it? It has a very high electronegativity. So it must be much harder to pull it off of fluorine. It's also closer to the pull of the nucleus, less shielding. So as I go down, it becomes easier to remove the electron. So as I go down, the ionization energy decreases. It needs less energy. So it's going to be 8C. 8C. Question 9. How does the lithium form the stable ion? Okay, so lithium's in group 1, which means it's going to want to lose 1 electron. So atom loses an electron to form a positive ion. So 9 is C. 9 is C. 10. What combination causes the strength of metallic bonds to increase? Well, I wrote down the melting points of sodium, magnesium and aluminium. And so if you look at the periodic table, you've got sodium, magnesium and aluminium. So the metallic bonds are stronger in aluminium, has a higher melting point, and weaker in sodium, has a lower melting point. And the reason is aluminium has 3 plus ions, and each of those aluminium ions have dropped 3 electrons into the sea, compared to the much bigger sodium ions, which are only plus 1 and only drop 1 electron in. So this is the stronger one. How do I know it's stronger? Because it's a high melting point. How would you know that without the data book? Just have to know it. So the charge on the cation is larger. It's D. So it's 10D. The smaller this is, the stronger the bond, the higher charge density. And the higher the charge on that plus ion, the stronger the bond. or electrostatic attraction. Question 11, incomplete octet. The IB has cocked this up in the past because hydrogen appeared in multiple answers. Hydrogen has an incomplete octet. It is, after all, a duet. Okay, NF3, I'll do it in the rigmarole way because in case you don't know how to draw these. So nitrogen's in group 15 and fluorine's in group 17. So I'm going to add up the valence electrons and divide by 2, which gives me 13. Nitrogen goes in the middle because it's the first one, and I spread the fluorines out evenly. Join them up, never in a ring. I've accounted for 3 electron pairs. I have to account for 13 in total, so I need another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stable octets all round there. BF3, boron's in group 13, and fluorine still is in 17. I need electron pairs, so that's going to be 20, 24, it's going to be 12. Boron goes in the center, fluorine spaced out, and I've got to put in another 9 lines. I've accounted for 3 electron pairs, I need 12 in total, so I need 9 more lines, and that's the answer, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, boron's stable with 6 or 8, so the answer is going to be 11B. 12, which compound has hydrogen bonds between its molecules. Well, if you're going to have a hydrogen bond, you're going to have so it's either H with F, H with O, or H with N. So that's out, and that's out. So that just leaves me with those 2 molecules. This one here I happen to know is methanol, because that's the only way you can draw it. Carbon has to have 4 pairs of electrons, oxygen has to have 4, hydrogen has to have 1. And this one here, they've drawn it out in a tricky way, but that's actually just methanol. So you can see here that the hydrogen isn't attached to the oxygen, it's attached to the carbon, and so that's going to be wrong. It's going to indeed be methanol. But so methanol, that's going to be 12B. But while we're here, this is not a hydrogen bond. That's a covalent bond, that one there. If you want to show a hydrogen bond, you'd have to draw another molecule. After all, it's the bond between the molecules. And there's your hydrogen bond, there and there. So the answer is B. 13, Hesse's law. These have a way of working themselves out. So don't forget, you can, if you flip the equation around, you have to change the sign. And you can double everything, you have to double delta H. You can half everything, you have to half delta H then. So I can see I've got 4 aluminiums, aluminiums, and I've got 2 there. So if I'm going to have to double the top equation. That's fixed the aluminium. What's next? And the MnO2, well, it's on the wrong side, and I need 3 of them. So I bet I have to flip this around and then multiply by 3. I'm sure that's all going to work out without me adding it up and doing all the rigmarole. So what answers that? So I'm going to end up with minus 1670 times 2 plus 520 times 3. What one's that? Is that D? 13D? Yeah, 13D. Okay, question 14, average bond energies. Alrighty, so on the reactant side, I have to break apart the bonds to make the atoms. So that's going to be endothermic, it's going to be delta H positive. These have to be positive numbers. And on the right-hand side, I'm going to be bringing the atoms together, making bonds, releasing energy, releasing heat. Oh, I feel the heat. That's going to be negative on this side. All right then. And then just add it all up at the end. So I've got 4 carbon hydrogen bonds, so that's 8 actually, so 8 times 414. Is that enough? 8 times 414. Is that enough? Is it just C, because it's that? That's it, C. That's the only one with 8 times 414 that's positive. Lovely. Question 15. What's the activation energy of the forward reaction? Well, if you're going forward, you always start from this line here, whether you're going to be doing the delta H or whether you're going to be doing the activation energy. You always start from where the reactants are. There we go. So that looks like it's going to be B, 15B. Yep. Okay, so question 16. I'm not going to rush into this. It's the hardest question. Barely anyone got it right. And it's the least discriminating. If you're good or bad at chemistry, it doesn't make any difference. Whether you got it right or not. It was equally, you couldn't tell the difference. All right then, so it looks like a Boltzmann distribution. If it was Boltzmann distribution, then this would be the hot line, and this would be the cold line, and then we're off to the races. And that's the answer I suppose everyone gave. But it isn't. It says that there's 2 different gases, X and Y. They're in this box, but the different boxes, separate boxes, same temperature. Temperature's the same. If the temperature's the same, then the kinetic energy must be the same. Which means the half mv squared must be the same for both of those. It doesn't feel like it's really on the syllabus either, but they do ask questions about it. So C and D must be wrong. C and D must be wrong because they say that one has a higher and one has a lower kinetic energy on average. No, the kinetic energy is the same. How do I know the kinetic energy is the same? Because the temperature is the same. How do I know that? It says it in the question. So it has to be A or B. Now it says that I can see that X is slower. This is slower on average, which must mean that this speed here for X is low and the speed for Y must be higher. But if they have to equal, that must mean the mass must be the tricky thing that's going on here. So that must mean that this mass must be bigger and this mass must be smaller to make it work. So the answer is A. X has a higher mass, higher molar mass, 16A, is it? Yeah. That was a stinker. 17? Which has the greatest reaction rate? So the concentration of HCl, if the concentration's higher, that's going to make it go faster, more collisions per unit time. So it has to be A or D. And if I powder up the chalk, if I increase the surface area, then there's more surface for the acid to attack it on. So I want a high surface area, so that's going to be A, 17A. Yep. 18, second easiest question, Kc. So Kc is just products over reactants raised to the power of their exponent. That 2 went there, that 2 goes there, and multiply them, don't add them. So that's going to be, that's D, isn't it? 18D, yes, 18D. 19. What's the pH of that? So my charge is 1, 3, 11, 13. Sodium hydroxide's a base, so bases have a pH above 7, so it can't be that, it can't be that. Another way of writing this is 10 to the minus 3 And that -3 gives you the tip off there. It's something to do with 3. In fact, the POH is going to be 3. That 3 goes to there. But I thought it wasn't 3. Yeah, the pH isn't 3. The POH is 3. So what's the relationship between pH and POH? They add up to 14. So that gives me C as my answer. 19C. 20, unpolluted rain. Well, all of these gases are present in rain. All of these gases have natural and anthropogenic man-made sources. But the IB likes you to know that regular rain has a pH of 5.4 due to the carbonic acid formed when carbon dioxide dissolves in it. Here's the equation. Carbon dioxide and water makes carbonic acid, a weak acid. So it's going to be B, isn't it? 20B. Yeah. 21. What contains nitrogen with the highest oxidation state? Okay, there is no rule for nitrogen's oxidation state because it changes. But there is one for oxygen. Oxygen in a compound is always -1, -2. The exception is H2O2, where it's -1. But here, it's just -2. That equals -1, because of that -1 there. That equals -1. That equals 0, because there's no charge, and that equals 0. So what's that going to be? That's going to be +5, +3, +4, +1. So is it the highest or the lowest? Highest. So 21's A. 21 is A. 22, oi. What happens to the salt bridge? Okay. So this is how I do this one. So the electrons are going this way, which means that this must be the negative electrode and that must be the positive electrode. Now what the salt bridge does, it balances the charge in the half cell. Now, as the zinc 2+ is formed from the zinc, what's happening is as zinc 2+ is coming off like that, this negative electrode is being swamped by these positive zinc 2+ ions. How do I know that the zinc 2+ is falling off there? Well, zinc is going to zinc 2+ plus 2 electrons. Look, these are the 2 electrons that were shooting around here. So I know that this electrode here must be the one that's giving off the electrons. So zinc is turning into zinc 2+. Now that's bad for the negative electrode because you're swamping the negative electrode with positive ions. And so the negative ions from the salt bridge come down and neutralize that charge buildup. So the negative ions go towards the negative electrode to neutralize the buildup of the positive ions. So flow to the copper. Is that B? 22B? Yes, 22B. Oh, that's a stinker, that one. I suppose you could just remember that the negative ions in the salt bridge go towards a negative electrode. 23, reaction occurs. What takes place at each electrode? So I've got magnesium turning into magnesium 2+, magnesium turning into magnesium 2+. There must be 2 electrons there, eh? So that's going to be... Well, we have to decide, is that the positive or the negative electrode, don't we, first of all? If this is the magnesium and that's the silver, I know that this is the negative electrode because, for the same reason above, the magnesium is giving off all these electrons. These electrons are shooting around. So the negative electrode, it's C, isn't it? 23C, yeah. Okay, that looks worse than it is. 23C. 24, what has the lowest boiling point? Okay, sticky sausage, non-sticky balls. That's how I remember it. Sticky sausage, non-sticky balls. Lowest boiling point, non-sticky balls. So it's that one. That's going to be 24D. 24D. Why are you saying that, Thornley? Well, molecules that are sausagey, molecules that are spherical, the London dispersion forces is to do with the surface area of the molecule. The more surface area, the more London dispersion forces. The least surface area, the less London dispersion forces. And it's the London dispersion forces that are holding those molecules together. Okay, 25. What goes in the middle there? Well, if you've got ethanol, there's only two ways to get ethanol. Remember, you've got ethanol, ethanal, ethanoic acid. So I can go backwards from ethanoic acid to ethanol, it's reduction, or I can go forward from ethanol to ethanol. So I think that's what's happening here. So if I put that there, now how do I turn that into that? Well, all I've done is I've swapped an OH minus for a Br minus, haven't I? So that's what's happening there. Okay, so that's going to be A, isn't it? 25A? Yeah, 25A. 26. What type of that? Remember, this is initiation, propagation, termination. What was that first step? You had chlorine. The ultraviolet light came in, didn't it? And it broke apart that bond. And so it broke the bond in two, and the chlorine's got its electrons back again, didn't it? So that's a fission or fusion. I say the worst food I've ever had was Czech-Mexican fusion. I like Czech food, I like Mexican food, but together it was awful. So fusion is where you blend it, and this is breaking stuff apart. So that's fission, isn't it? Fission. And am I making the same stuff, homo, or different stuff, hetero? I'm making the same thing, this and this. Okay, but I did swap out a chlorine for a hydrogen, so that's substitution, isn't it? So free radical substitution. Yeah, these are free radicals here. So that's going to be 26A. 26A. 27, what's the name of that one? Everyone got that. So what's the longest chain? 1, 2, 3, 4, 5, 6. So that's going to be hexane. I want to get the lowest numbers. Oh, that's generous. It doesn't matter which end you count from. I'll count from this end. 1, 2, 3, 4, 5, 6. So there's something on the 3 and there's something on the 4. There's a couple of methyl groups. So 3,4 dimethyl hexane. Which is D. 27D. 28, second most discriminating. So density is mass divided by volume. If you're doing multiplication or division, your answer has to have the same number of sig figs as that which has the least in the question. What does that mean, Thornley? Well, the mass has 3 sig figs from looking at the table. And the volume has 2 sig figs. So which means my answer must have only 2 sig figs. So it's going to be B, 28B. That seemed too easy. I made a mistake. No, 28B, there we go. If you were adding or subtracting, it goes with the decimal places, not the sig figs. 29, second hardest. So the IB apologised for this, because if you tried to map the data from 28 onto 29, people got confused. They're independent questions. And they don't overlap at all. So if I collect the data for mass and volume for silicon, well, the bigger it is, the more massive it is. So imagine my data is going to look like that. So that's my slope here. So slope is going to be mass over volume, rise over run, which is indeed density. So yes, I is correct. Density is the slope. 2, the data will show that mass is proportional to volume. Yeah, double the mass, you're going to double the volume. That's right. And 3, the line of best fit should hit the origin. Yes, should hit the origin, the line of best fit. If I've got no mass, I've got no volume. That makes sense. So that one's right as well. The only thing you're sure about is that it should go through 0, 0. Everything else, you're less sure about. 0, 0 is the only thing you know is true. So that's 1, 2, and 3, which is D. 29 is D, and 30. Infrared. Okay, so infrared measures the different sorts of bonds, doesn't it? Is it a CO? Is it a HF? What sort of bond is it? Mass spectrometry, don't forget, that's where you cut things up. X-ray crystallography, that's where you work out the distance between the atoms in a crystal. And H1NMR will find out everything you want to know about the hydrogens. So for infrared, it's going to be types of bonds present. So 30 is C. And we're done. I'm doing these a bit faster. That's not a Duchamp smile. Duchamp smile didn't go to my eyes. I'll try again.